Hello guys, so now we are going to move another workflow of LangGraph, so that is called orchestra workers. Okay, so orchestra worker workflow in LangChain. You can see here in the orchestra worker pattern a central LM, the orchestra. Okay, so it dynamically break one task into a smaller subtask. Okay, each subtask each subtask is sent to the worker LLM, and finally the orchestra combine the result. Okay, you need to create a subtask for each task, and finally the orchestra combine these results. Okay, and here when to use for complex task where cannot predefine all the subtasks. For example, writing the report where number of the section and content depend on the main topic. Key reference from parallelization: subtasks are not predefined; they are created dynamically by the orchestrators. Okay, here this is for start, and this is the orchestra. It divide a work for worker 1, worker 2, worker 3 in parallel way. Okay, then it will synthesize it and end it. Okay, here you can see orchestra node. These are the nodes 1, 2, 3. So generate a plan. Okay, generate a plan list of section for a report. Decide what subtask need to be done. Okay, here generate orchestra node. And then worker nodes. So each worker node handle one subtask independently. These are the subtasks. This will decide, how many subtasks will create it by it, and then it will divide subtasks that this node do this task and other node do. I mean, other 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 task will do by this node. Okay, and other task will do by this node. Okay, these are working parallelly. So each task handle one subtask independently. Worker can run in parallel. Output are written to a shared state so the orchestra can access them. Okay. Synthesize node combine the all worker output into a final result. Okay. Here you can see this is the orchestra. It decide the task, and this will give to the node 1, node 2, node 3, and combine the task here and give you result. Okay. Orchestra decide what section the report will have. Okay, what section of report will have. Worker each write a one section independently. These they will do things independently. I mean, their task they will do independently, not by like a, you can not taking a help of any other node. Okay, so after this assign the worker, send each section to separately worker dynamically. Okay, and synthesize combine the all worker output here, and complete the report and generate the output. So here I'm going to import these things that we can access API from ANV, and this is a for model. I'm going to use llama 3. Okay, there here I'm going to invoke result inquiry. Okay, here I'm going to import annotate list. Okay, operators, literals, base model field. By using pydantic, I'm going to import base model and field from LangChain underscore core dot message import human message system message, and from type extension import type date. Okay, and this is the type, and this is for also typecasting type extension input literal, and import operators, and from typing import annotation and list. Okay, this is for add if you want to add something. Okay, so here schema for structure output to use in planning. Okay, so this section this is the this will create orchestra create a section. Okay, so name equals to string, field in field description equals to name for this section of the report. Okay, so here in description should be in string. So here in the inside the field description equals to brief overview of the main topic and connection of the section. Okay, so here orchestra creating a section, and this is the another class sections. Okay, section should be in list. Okay, here I'm going to pass sections. This one, this is for one, this is for multiples. Like a section should be in list. Okay, and inside the field section of the report. Like if you have a report and the report have different sections. Okay, and planner augment the LLM with the schema for structure output. So planner equals to LLM dot with structure output. Okay. Now creating worker dynamically in LangGraph. So here you can see I'm going to create a orchestra workers workflow. Creating a worker dynamically in LangGraph. Okay. So here I'm going to import these things. Okay. From LangGraph constant import send an import operator, and from typing extension import typing, and this is annotate import from typing. Okay, this is the state that we can flow global workflow of state. Okay, so state are used to it is used for global information share across the workflow. It is used for share the information between the nodes. Okay, you can say, and these are the variables we are going to use. Topic, like if we have any topic, so that should be in a string. Section, like if your report have multiple section, that should be in list. Okay, section, this is for multiple section, this is for one, like section 1, section 2, section 3. Okay, completed section. So here I'm going to annotate add the all section here. So all worker output, like worker 1 do one section, and worker 2 do another section, worker 3 do another section. I mean, this is the work. Okay, so here I'm going to combine this section here as a output. So all worker output merge, and operator dot means the operator dot add means merge the output from parallel worker safety. Okay, so here like if all worker doing thing parallelly, so here we are going to add this thing here. Okay, operator dot add, so we are going to add by using operator dot add, so that's why I was import operator. Okay, and final report should be in string, combine the final report. So here each worker's local state. Okay, so here this is the section, this is the class worker state. Here I'm going to pass type dict. Okay, that we got result in a type dict. So section equals to section. This is for one single. I mean each worker. This is for worker one by one, like each worker, for worker one, worker two, worker three. Okay, so section equals to section. Okay, completed section annotation, and here worker output appended to the global list. Okay, this is for one worker, and this is for annotated list for multiple workers. Sorry, this one. And here the LangChain deprecated. You can see whole document of LangGraph. Sorry, LangGraph or LangChain. LangGraph is deprecating LangGraph documentation. I'm going to click on this. You can see LangChain, LangGraph. Okay, here you can see uh, from this page also deprecated and removed in October 2025. I don't know when will you see this lecture, so you can read. If any library deprecated, you can go through this document, and you can update your library according to this document. Okay, and now I am going to create orchestra node. Okay, so here this is for orchestra. This one, that it will create a sections. Okay, and I'm going to pass here a state that it will flow the information. This is the description of this function, central LLM that plan the report structure. Okay, this is the central LLM. This will define the report structure. So here ask the planner LLM to create the list report section based on the topic. Okay, so here report section equals to planner.invoke. Okay, so system message content equals to generate a plan for the report. Okay, and human message, here is the report topic. Okay, state inside the variable is topic. Okay, so human giving the topic to the AI system I mean system, and system have content like generate a plan for the report. Okay, and print report section. And so report section here I'm going to print a report section. Okay, the report section equals to planner dot remove, so I'm going to print report section, this one from this. Okay, so return section report section dot section, that it will return sections of report. Now I'm going to create worker nodes. Okay, so this is for LLM call. Okay, state equals to worker state. Okay, so worker LLM write a single section of the report. Okay, each worker writes single section of the report. So section equals to LLM dot invoke LLM generate content for assigned section. Okay, so here you can see system message, write a report section following the provide name and description, include no preamble and use markdown, and human message this one. Okay, content section name, and inside this is the section dot name, so we got the name for section here, and return the complete section dot content. Okay, so assign the worker dynamically. Here you can see this will automatically assign the worker. Okay, so create a worker for each section for the plan. So here you can see return send LLM call and section colon s for s in the state section. Okay, here applying the loop. Okay, for loop for these workers, that automatically assign work for this one, for this one dynamically. Okay, now synthesize the node after assigning the work to the all worker. Now combine the all completed section into a final report. Okay, in synthesizer. Okay, so complete section equals to complete section. Okay, and here complete report section equals to for another line. So I'm giving to this one means we are moved to another line. Okay, so we are join this line and complete the section and return final report and complete the report section. Okay, so after this this is for a generator. Okay, so this is for orchestra, that it will create a report and section, and this is for worker nodes. Okay, one node for single section of the report, that it will generate a report and assign the task to the worker. This is the for report, that it will generate the report and then assign the task to the worker and combine the task, all tasks combined here. Okay, now this is the build the workflow by using graph. So here I'm going to import these things. Okay, these two. I'm going to import state graph start and by using LangGraph.graph. Okay, I already explained these things lots of time, so I don't need to explain it again. Okay, I also already explained it, but I can also say here from ipython.display import image and display. Okay, that we can display image of graph. Okay, this is for access the this line for initialize the graph. Okay, orchestration worker builder, so state graph inside this state. Okay, so these are the node. Okay, worker builder add nodes, these are the first node, orchestra. Okay, so here this is the node for this one, orchestra, that it will plan. Okay, and here after this orchestra worker dot as llm and llm call these node. Okay, here I already decided for report section it will create a report. Okay, and this is the synthesizer for combining the task, create report and dynamically distributed task to the worker and combine the task here. So this is the another node, and after that now connect now age will be connect to the node. So here this is the age orchestra worker underscore builder dot age. So start from orchestra. Okay, orchestra worker builder dot conditionalizes that orchestra assign worker. Okay, assign the worker task. Okay, so orchestra worker builder dot is llm synthesizer here. This is for combining the yeah, all the tasks here from all the workers. Okay, orchestrator builder dot as dot add underscore is synthesizer and add. Okay, so now compile the graph by using this thing and got the image in the Marmot PNG. Okay, so start orchestra is used for generate the and plan and generate the image. Sorry, generate plan of the report and generate its section in multiple section and create its subtask and it will distribute here dynamically. It will distribute the task for different worker that these worker are and these worker completed their task in parallel. Okay, now after complete the task they will combine the all task here and it will end here. Okay, now I'm going to ask the question here. State equals to orchestra workflow, this one. Now orchestra workflow dot involve topic equals to create a report on agentic AI rag. Okay, so from ipython dot display import the markdown that I got answer in markdown state final report. So this is the final report. Okay, you can see here introduction of generative AI, agentic AI. This is the for report section name, section name. Okay, and this is the response introduction to agentic AI. Background content definition. Agentic AI refer to the agentic artificial intelligence research group. Okay, agentive content key definition. AI system that exhibit autonomous behavior, decision making and adaptability. Okay, what are the agentic AI reg? Okay, so here these are the things I got. Okay, this is the response generated from the what, from this one state equals to orchestrator whatever dot invoke and topic create a report on agentic AI reg. I hope you like my video. Bye bye, take care.